Gentlemen, welcome back to the shop. We're going to do some more machining on our gyroscope project today. We've got some 1.25" aluminum chucked up, and this is going to mount to our base, and it's going to be what basically supports the top of the gyroscope. So what we need to do is face this off. We're going to drill it 15-30 seconds, about 1.75 inches deep, and then we're going to bore it out to fit a bearing in there, which is going to be this one, and we're going to have a shaft that goes down through that supports our gyroscope, so it'll allow the whole thing to spin axially. And then we'll probably drill and tap this and make a like a little brass locking mechanism so that you could actually lock that as well if you didn't want that to spin. So we'll go ahead and get this face drilled, bored out, and then we're also going to thread it so that we can put a cap on it, and we'll cut a hole in the cap so it so it looks nice with just the shaft sticking out of there. So it should be pretty nice. Got some ZZ top on, and let's go ahead and machine this down. Alright, we're faced. Now we need to go ahead and drill it, so we'll center drill it first, and then we'll drill our 15-30 seconds hole in there. And we're going to be drilling 1 3/4 deep, so we're just going to set our depth. Tailstock at 1 inch here, touch off, and then we'll go into 2 3/4. Alright, we're right on there. Alright, now we're going to go ahead and bore this out, and on my notepad we need to bore it out 1 inch diameter, 450 thousandths deep. We're just going to use a 1/2 inch boring bar is all, and we're going to set our zero. Alright, so we got our zero set. We're going to go in 450 thousandths and bore it out to 1 inch OD. I think we should be there. Exactly, right on 1 inch. Okay. Now we need to machine in our bearing race, and that is going to be 943 thousandths in diameter, and we're going to go 234 thousandths deep. Okay, that should be it. I'm actually going to go in and make a little relief for the inner race, just so the inner race doesn't contact the aluminum behind it at all. So we're just going to touch off, and we'll take maybe 10 thousandths is all. Okay. Perfect. Alright, now that we got our bearing race machined, we're going to go ahead and thread this. So first we're going to make a little cut up front here. so our threads won't start immediately. And then we're going to cut our thread relief groove. This tool just has a little just a little internal grooving, you know, it's for like internal O-rings or internal grooves or thread relief or whatever you want. Okay, we got our thread relief. Now we're just going to take some layout fluid just so we can see our threads and just okay. Alright, now we're going to go ahead and thread this. So I've got an internal threading tool that I ground on here. We need to flip our compound around. Alright, so what I'm doing is just going in until my threading tool just scratches the metal there, and then we're going to set our zeros on the cross slide and set our zero on the compound, and then to thread it we're just going to use the compound to go in about 5/1000ths per pass and cut those threads. So we got our speed set, we got our lead screw, and we got the transmission set to 28 threads per inch. So we can go ahead and cut these, and we're going to go, the double depth is 46/1000, so we're going to go about 23/1000 deep on the compound to get our threads. Kind of a rule of thumb too is an approximation is when you can't see the layout fluid anymore, so you've cut down until the peaks of the threads are maybe just stained with layout fluid, or just gone is about right. So we'll go ahead and thread this. We'll take our first pass here. I'll dial in just a couple thousandths so we get a little scratch. We can make sure it looks good. Go back out, we come back to our zero on the cross slide, and then we dial in another about 5 on the compound. Take a second pass. Alright, we're just going to keep doing this until we've got our thread depth correct. This should be about our last cut. We'll cut this, see how it looks, and then we'll probably do one spring pass. Alright, yeah, that looks good. We'll do just one last spring pass just to clean them up. Alright, our threads look pretty good. Put our chamfer tool in here. This is the lead screw. Set our speed. And then we're just going to touch this edge. Okay, perfect. Alright, so what we're going to do is finish up the outside diameter of this. And I've got a bell center that I made here since my regular center won't hold that. The hole in it's too big that we bored. So we're going to feed the screw backwards, and we're going to do it this way, because when we get to the end here, I can't reach down in there with a right-handed turning tool to turn that. So we're going to have to feed it backwards and clean this up. So we'll go ahead and do that and get this done. Should be pretty quick. need to do one more pass. We didn't quite get it all, so we'll do one more light pass and we should be good. Alright, looks good, so we'll go ahead and cut this off. And then on the reverse side, we've got a thread at 7/16 by 20, so it'll screw down into our base. And then we just have to chamfer this edge right there. And then we'll drill and tap this so we can put a nice little brass locking handle in there to lock the rotation of the gyro. And then we'll be done with that piece. Alright, so we've got this parted off, and we just need to chamfer this edge right here, and then we'll flip it around and tap the other side. Okay, that's it. I put some masking tape on this so our jaws don't mar up our surface. We could always hit it with some sandpaper, but it's easier not to. Alright, we'll go ahead and face this off. Okay. We're looking for 436 thousandths diameter. So we got a little ways to go. Okay, we're going to use our parting tool and cut a thread relief. Okay. Now we're going to put a little chamfer on the edge. Alright, now we can go ahead and cut our threads on here. Okay, those look pretty good. Alright, all done with that. We can go ahead and mount it up. Put our bearing in and mount that to our base. We're all set. Alright, we're going to go ahead and make our brass locking handle that's going to lock our gyroscope from spinning axially on the stand. We got some 5/8 inch brass. I'm going to face this off, turn it down and thread it 5/16 by 24. And then we'll part it off. We'll probably cross drill it and then put like a little T handle through it. So let's go ahead and get this done. Alright, so we're just going to go ahead and take a little bit off just to true up the surface. I think we'll go ahead and use the feed actually to do that. So let's get that set up. that looks good, and then we need to take this down to 311 thousandths in order to cut our threads. Alright, we can go ahead and cut our threads. Alright, go ahead and chase them. And I think we'll go ahead and cut a little relief groove. We probably should have done this first, but it's alright. Alright, that looks good. We can go ahead and part this guy off. Alright, we'll go ahead and face the other end, maybe put a little bevel on it and then cross drill it, and we'll make a pin to go through there. Alright, we can go ahead and do a little bit of assembly. So we've got this piece that we machined earlier. I pressed the bearing in. It was a very light press fit in there, and then drilled and tapped this hole 5/16 by 24, and this is where our locking screw is going to go. Our locking screw, I parted this off, went ahead and faced and kind of beveled the other opposite end there, and then I cross drilled it 3/16 because I had some 3/16 brass rod that we can go ahead and use as our T-handle. So what we're going to do is we'll just slide this in, and we'll put a bit of locking compound on there. I'll slide this through, get it centered up. Okay, we're going to go ahead and let that sit and harden. I've did another one, so we have one here that's already dry. We can go ahead and thread this in here. Sorry about the compressor. So you can see, I don't know if you can see in here, but when you thread this in, a little bit is poking through there, and that's all we need. And then I didn't video machining this axle or shaft that's going to go in here, but this is just some steel, and it's threaded 7/16 by 20 on the end, and this is going to thread into our gimbal. And then this is machined down to just fit inside that through hole that we drilled in there, and then this bit right here is machined to the same diameter as the ID of our bearing in there. So this will fit right in here, and then it'll turn, allow our gyroscope to turn axially, and then if we turn this in, that'll lock that in, and so it'll lock that tight. Now is what we need to do is machine an end cap for here, little thread on there, and so you'll end up with just a little bit of this steel poking out. Have a nice looking top on there. And then also, since we threaded this, we can go ahead and thread this onto our base. That'll be just like that. We might add some, just drop a Loctite or something on there here. So our top cap will be on there. That threads in nice, and then we can zoom out here. It's about as out as we're going to get. And then on top of here, we need to machine these flat, these two surfaces, and then we'll probably make a brass cap with some really small screws on there, and then notch, just machine a little, probably a V in there to hold the next gimbal and allow that gimbal to rotate this way. And then you can just snug those screws down on that, and maybe we'll do a bronze bushing or something in there. We'll have to see. There's that. So that's gonna, yeah, this will work great. So it's looking good so far, coming together. And we're almost done.